So who am I? I'm working as a researcher in Lablup since 2020. My main role is to make Backend AI demos, test Backend AI new features. Also in Lablup we have research team where we work on various different research projects. For example, I was part of a project where I tried to predict if young mouse brain will get a brain disease in the future using machine learning, which were those models trained on mouse brain EEG recording. And currently, Lablup research team is working on predicting the infection risk of airborne disease based on distance between people, duration, and ambient environment in the room. I have various previous experience. For example, I was working in Korean company Who's with environment, social, and governance data. I was data scientist, and I also graduated master's degree from KAIST, from Department of Knowledge Service Engineering, which is changed its name, and it's now Data Science Department. I will introduce the VisuTale. So we will check what's this service, and we explore AI models, and I will tell you why you should care, why this is interesting things. And I provide the code snippets and code examples, such as blueprint, how you can do same thing on Backend AI, and we will cover some generative AI models and explore the tech powering behind VisuTale. Imagine a world where you go to a vacation to different countries and you see a beautiful sunset around the sea, and you decide to use your photo to capture your unique moment using your smartphone camera. This camera takes the picture, and based on this each individual pictures, it creates a unique story with story-based images. So this is a demo video. For example, it's hosted on our Backend AI cloud with our domain name, VisuTale, and the user can select multiple languages, and it can make a customized art style. And user can, using a smartphone, go to QR code and select images, but it also can be done from laptop locally. For example, I selected the fox, the Disney castle, and basketball ring. So images are transferred to the session. First, the Lava language model, it tries to understand what is displayed on the images and tries to make some image captions. For example, this is a castle, and if we go to the next image, the vision model understands this is a fox, and it can see some background behind of that. And third image was about a basketball ring. So we have multiple images with multiple captions, and those captions are used by language model to generate a unique story. For example, the story about Cinderella who walks in the city, and she meets a red fox, and probably this, according to the story, they play basketball. And this is there are multiple images according to this story, and below the image generated images there is a text prompt which was extracted from the story and then was used for stable diffusion model to generate those images. So what are problem and what was the motivation behind this project? There are already many existing language models who can write a story, and there are already big models who can generate images and maybe image captions. But the problem is that those all big models are working in silos. They are independent and they are separated. And there was a need for creating a really unique user experience by merging all those models together and making some form of orchestration between multiple generative AI to create a unified narrative experience. What are possible business applications are for storytellers and marketers. Also, we tested among our team members that children really liked this product. Was really fun for them to play with such a service. And Backend.AI is the enabler for such a service. Backend.AI, it provides hosting environment for generative AI models. And as you have covered in previous sessions, Backend.AI provides environment which can help reduce the time from setting up, from prototyping to model inference. Backend.AI provides scalability in terms of load balancing between various models, and it's also easy of use. And in previous sections you covered different MLOps tools such as FastTrack, which can help you to build a pipeline for such a service. Let me go deeper in those models. To create this product, I used Lava Large Language and Vision Assistant model, which can do image understanding and captioning. Lava has a vision encoder, and it is based on language models such as Vicuna or Llama LLM, which can do describing what they see on those images and do some form of reasoning. The captions from the Llama goes to ChatGPT to generate a story, and in another round, ChatGPT extracts key points from the story. And then also those extracted key stinging points are converted to the Stable Diffusion text prompts, and based on this Stable Diffusion model, generates relevant images for a story. So this is a kind of general workflow between 3 large language models, but between each step, any user can do add some another tasks. For example, story translation by using ChatGPT itself or using Google API, and using iterative processing. Story can be enlarged for multiple pages, for example, or you may apply image resolution upscaling model to increase story-based images. Probably you already heard about ChatGPT or Stable Diffusion, but I will talk about Lava model, because this model is multimodal, which means it works with multiple modalities such as images and text. Lava is based on clip vision encoder, which transforms a given image into high-dimensional vector. And Vicuna or Llama architecture, it tries to extract from image textual features and transforms into text vector. Projection matrix used to encode to do mapping between image, high-dimensional vector of image vision encoder into text vector representation. And for second stage, we can do fine-tuning of Lava in terms of first Lava can understand what it sees on image, and in stage 2, Lava can do image reasoning and question answering, for example, in more detailed and in more very descriptive way. And how Lava works in simple way. For example, we have language instruction, where users ask a question, describe me the image or what's unusual about the image. And we have input as image matrix. And then projection matrix modifies this image matrix into similar textual vector, which goes to language model, and language model provides a response. Let me explain in more details how vision and text feature alignment are working. It's common not only for Lava but for other multimodal models. So if we take a vector X from vision encoder, and we have data set where images are paired with textual captions, so we can get two vectors, image vector and text vector, and then we can have a projection matrix, which can help us to minimize the distance between image vector, dot product of image vector with weight matrix, and text vector. And the training process is done by calculating the loss, for example, the distance between modified image vector and text vector using deep learning loss optimization algorithms. And this training process is not neural network, because neural network has multiple layers and activation functions, but this is just matrix simple linear transformation. And it's not PCA, because PCA is unsupervised, but in our case we have supervised learning. What can be the future of VisuTale? With Backend.AI we can do multi-user scalability, so we can support multiple users, and we may add audio generation for a story by adding audio generation text-to-speech model. And in the future, if we have a large training set such as user images and generated story and generated images, we may create our own model which directly generates a story or directly generates images from uploaded user photos. And in that way, we can reduce the number of physical GPUs are used from 3 to 1, for example. Also, VisuTale is a good example. Some people think that AI will replace human creativity, but VisuTale shows a good example of how human can still be part of creative process. And how you may set up such a service on Backend.AI cloud, I provide some examples. And this is outline, which we will talk about. First, I describe how you can create a Backend.AI environment and how to set up Lava and Stable Diffusion. And we can talk about requirements and how to orchestrate Lava and Stable Diffusion with web server. Basically, it's 1, 2, 3 step for setting Backend.AI environment. You may select PyTorch image, and then you do resource selection. For example, you need 3 physical GPU. You select 3 physical GPU and appropriate amount of RAM. Then session started. You can choose Jupyter Notebook or Visual Code as working environment. And thanks to Hugging Face, most of language models and vision models are hosted on Hugging Face portal. So, for example, you can do git LFS install to enable download large binary files, and similar to GitHub, you can clone source code from Hugging Face into Backend.AI environment. For example, you may clone Lava specific versions such as Vicuna 13 billion, but there are also 3 billion and 7 billion. And you may clone Stable Diffusion with image refiner, and then you do installation Transformers library. Transformers library provide functions to interact with Stable Diffusion models, and Lava PyTorch provides Lava functions to interact with Lava. So depending on the number of AI models, if ChatGPT is API based, then it's 2 AI models and 2 GPUs. But in previous session in Lablup, we also have Llama 2, which is hosted on Backend.AI. However, ChatGPT provides some more interesting and better story making at this moment. And 13 billion Lava takes about 32 gigabytes of RAM, because Lava is a vision and both and language model, so that's why it has high consumption of RAM. Actually, the most core code of Lava and Stable Diffusion you can read from GitHub, from their GitHub pages, and this is example shows how to integrate such a code into Fast API server, for example, for the API endpoint. When user submits a photo, so we can see that API endpoint caption receives the uploaded file image, and then it converted into PyTorch tensor. And then we are looking for, we prepare instruction template for image captioning. For example, for the question, what do you see on the picture? Is there anything unusual about picture? Provide answer in 5-sentence answer. And then Lava can see this instruction and completes this template. And with input IDs, we do text tokenization, so we convert text into stream of integers. And then we instantiate a model with torch inference model. We insert all input parameters. And when Lava does the inference, its output, we do decoding the output. We convert integers into our text. And this slide provides example of how we can use Stable Diffusion. Using Transformers library, we define the model path for binary path for Stable Diffusion, and we select the version, and we set some properties. And for generate image endpoint, Stable Diffusion model receives text instruction. So we have template, for example, cartoon for kid, and it's 2D animation, and then user instruction appended, and this instruction comes from this generated story-based scene. Then we define two models where the input is user story scene, and based on this image, Stable Diffusion generate image, and it saves image into specific path. And it returns the response, converts the image into byte array. Next, we talk about the web server. So you may create the web interface using any language. For example, you may use React.js or Python frameworks. And this is done using Python Streamlit. So first block with line 215, we define image uploader. And then with second block, we do image captioning. We send the input into the caption function, async caption image. And in third block, we check for instruction. We provide instruction for ChatGPT plus image captioned text. And then, for example, ChatGPT can see story should be less than 500 words, and then ChatGPT, based on this instruction, generates a story, and using Streamlit library, we display some in HTML text like story and the output. And in the next block, we write a story, and we extract from generate stints, we extract key stints from a story, which are then sent to Stable Diffusion model. And by continuing this code snippet, and based on key extracted stints, we fill some user interface blocks with title, story, and generated prompts. And we do sequence image generation here. After that, the PDF report is created, which can be downloaded by QR code, which points to specific link for download. So in conclusion of this presentation, we demonstrated VisuTale service, how it can be serviced on Backend.AI. We talk about AI models used in VisuTale. I described the feature alignment in Lava. Also, we talked about Backend.AI raw and why it's good and its advantages. As well, we mentioned of possible future of VisuTale service if there will be big interest and demand for such a product. And I explained it in some short session about how to set up those generative AI models and how you can run on Backend.AI cloud. 감사합니다.